And welcome back, everybody. So this is a video going over the practice test. This is the section 5.1 to 5.6 practice test. So here's what I would like to do. I'm going to go through question by question. Stop and ask questions whenever we need to. This is, it's going to take us a while. That's okay. Go through with your answers line by line. Make sure you know exactly what's going on. Like always, practice tests look a lot like real tests for math classes, so make sure that you understand everything about this stuff. Okay, let's take a look here. I'm going to start here with number 1. Using the graph of f of x is equal to x squared as a guide, describe the transformations and then graph the function. Okay, what 2 transformations do we see happening here? There are 2 transformations. What are they? What's the minus 7 inside doing? Right 7. Remember, inside is kind of the opposite of what you would normally think would happen. So if I see a minus 7, it's actually going to move it to the right 7. And then this plus 8 is going to do what? Up 8. Now remember, if I want to graph this, this is in what's called vertex form, right? So this means that all I need to do here to graph this, let me get a graph up here, is just go right 7, up 8. Right 7, up 8. So there's my new vertex. Remember, there's my new center point of my graph. So I just go up 1 over 1, up 2 over 4, sure. Generally looking like that. Okay. Questions about that? Get there? Okay. Take a look at the next one. The parent function of f of x is equal to x squared is reflected across the x-axis, vertically stretched by a factor of 3, and translated 6 units to the right to create g. So I'm going to create my new function, and I'm going to call it g of x. Use the description to write the quadratic function in vertex form. Remember, vertex form, I kind of talked about it a second ago, but vertex form is that a times x minus h squared plus k, right? Where that a value is the vertical stretch or compression. A will also tell you that it's been reflected over the x-axis. So if it's negative, obviously it's going to be a reflection over the x-axis, but it will also tell you that whether there's a vertical stretch or compression that is happening. The h moves it left or right, and the k moves it up and down like we saw in the last problem. All right, let's go one by one here. Reflected across the x-axis and vertically stretched by a factor of 3. That means my a value is going to be negative 3. I can combine those 2 transformations to get my a value. It's reflected across the x-axis, so it's a negative, and it's vertically stretched by 3, so it's negative 3. So negative 3. And now, has it moved any left or right? Yeah, it's moved 6 units to the right. X minus 6. And then, has it moved any up or down? No, it doesn't look like it. Now, don't forget about the squared, folks. That's kind of a pet peeve of mine. Depends on the day, depends on my mood. If I take points off for that one, just put an x squared. If you don't have a squared, it's technically not quadratic. Make sure you write a squared, please, and make sure you're putting the parentheses in the appropriate location. Okay, so it's reflected across the x-axis, negative, stretched by 3. 3 on the outside. Now, again, I'm saying vertical because it's going to happen on the outside. If I had said horizontal stretch by 3, remember that's going to happen on the inside. Translation 6 units to the right. That's why you see an x minus 6 on the inside. All right, questions on 2. Here's 3. Consider the following. F of x is equal to 2x squared minus 4x plus 5. Determine whether the graph opens up or down. Find the axis, find the vertex, find the y-intercept, find the domain, find the range, and the graph. Okay, so first thing that I want to do is tell whether it opens up or down. Remember that I look for the a value. If a is positive, if a is greater than 0, then it's happy. Right? If a is positive, then it's happy. A is positive, it's happy. We know that this is going to open, I'll put this over here. We know that this is going to open up. Find the axis of symmetry. Now remember, for something in standard form, it's negative b over 2a. X equals negative b over 2a, which in this case My A value is 2. My B value is -4. Make sure you write it as a -4. And my C value is +4. No, +5. What am I looking at? +5. Sorry. +2, -4, +5. All right, so that gives me a positive, negative, and a negative, making a +4 on top over 2 times A, so 4. Okay, so 1 is my axis of symmetry. 1 is my axis of symmetry. Actually, x equals 1, right? X equals 1. All right, now to find my vertex, so find the axis of symmetry, done, find the vertex. Remember that axis of symmetry is my x value of my vertex, and all I need to do now is just plug it in. So it becomes 2 times 1 squared minus 4 times 1 plus 5. So 2 minus 4 plus 5. I think that's a +3. 2 minus 4 is -2 plus 3, or sorry, plus 5 is 3. So I've got it, it's opened up, x equals 1, my vertex is here. Find the y-intercept, the easiest of the values, just C, 0, 5. Now, finding the domain and range, remember the domain for any quadratic is all real numbers. People were getting fancy on the quiz, you were right. Ooh, fancy. The range, now the range is not all real numbers. It's always dependent upon where where the vertex is. Right? It's dependent upon where the y value of the vertex is. So this is 3 and it opens up. That's the minimum value, right? The bottoming out point. So anything above that value, above 3. Now I'm okay if you just had said y is greater than or equal to 3. But again, people got fancy and said, would have said this. Fancy. Okay, let's go. Okay, let's graph it. All right, I'll make a dotted line at 1. Okay. And then we've got 1, 3. And then our y-intercept is 0, 5. And I'll just reflect that point over to the other side. Round it out. Let me ask you this question. If I asked you to find the zeros of that function, seeing what it looks like, what do you know about the zeros of that function? They're non-real. They would have an I in them, right? They would include an imaginary number because they do not cross the x-axis. The zeros would be non-real. Okay. All right, let's keep it going. Find the zeros of the function by factoring. So as you can see here, I'm going to be asking you to find the zeros, find the x-intercepts by a variety of different methods. Now, please make sure you understand, folks, find the zeros means my answers should be x equals. All right, there's my answer blank. And I'm probably going to get 2 of them. So let's do this. Right? Now, a lot of people get confused because I say by factoring, and they think, oh, I'll just factor it, and I'll put that in there. Okay, yeah, I want you to solve the zeros by way of factoring. So I want to do this, x squared minus 3x minus 40 equals 0, and I want to solve for x. How do I want to solve for it? I want to solve for it by factoring. Well, is this an easy type or hard type? Sweet. -40 factors of -40, and I know that because there's no a term. Factors of -40 that add to get to -3, -8 times 5. So that means since this is an easy type, it's just x minus 8, x plus 5. Okay, don't put that on the answer blank. You've got to write x minus 8 equals 0, x plus 5 equals 0, x equals 8, x equals -5. Questions about that? Because again, I'm asking for the solutions to that equation. What values do I plug in to make y equal 0, to make the output equal 0? Heck, test it out. 64 minus 3 times 8, 64 minus 24 is 40. 40 minus 40 is 0. Perfect. Negative 5 squared is positive 25. 25, and then negative 2 times negative 5 is positive 15. 25 plus 15 is 40. 40 minus 40, 0. Those two values make that function go to 0. Take a look at 5. All right, a golf ball is hit from ground level with an initial vertical velocity of 80 feet per second. After how many seconds will the ball hit the ground? Remember, there are two types of projectile motion questions. One where I ask you how high it goes or what's the maximum value. The second one being how long does it take to hit the ground? Remember that the two values the two questions that I'm asking, one of them says find the vertex, one of them says find the zeros. This one is a find the zeros. Think about it. Here's my graph. No. That's what I want to know, right? That's the zeros. I'm going to have one at 0 because it's ground level, and the other one I want to know, that's going to give me my total time in air. So negative 16t squared plus 80t. Now, I would write plus 0, right? Because it's hit from ground level. Initial height, h0, h0, is 0. Okay. I want to know when this is going to happen. I want to know when the height is going to equal 0. So let's solve this. Negative 16t squared plus 80t is equal to 0. Now, we knew better, or we didn't know better back then. Like at this point when we were doing these problems, we were saying, I only know how to factor. So if it didn't factor, we were stuck. But do I have other methods now? Like, could I really complete the square or use the quadratic formula for this? Sure, if you really wanted to, but you have to be honest, factoring is a lot easier. Right, factor out the negative 16t. And how do I know I can factor out a 16? Well, 80 divided by 16 is 5. So I'm going to have t minus 5. And I factor out the negative because it leads with a negative. And that means that plus sign turns into a minus. So negative 16t equals 0, t minus 5 equals 0, t equals 0, t equals 5. 5 seconds. My 5s and my s's look similar. Question? Okay, can we keep going? All right, find the roots of the equation using any method. Oh, cool, we can use anything that we want. Let's do this. Well, again, finding the roots is finding the zeros. So let's get it into standard form and see what happens. 2x squared minus 20x plus 50x. Or sorry, just plus 50, right? I'm just moving everything over toward the 2. I don't want to make 2 negative. I'll make negative here. Okay. So we got 2x squared minus 20x plus 50. I can factor out a 2. You want to do that? Let's see what happens when I divide out a 2. Because maybe this might complete the square pretty easily if I divide out a 2. So I've got 0 is equal to x squared minus 10x plus 25. Oh, I don't even need to do that. What are the factors in 25 that add to get to negative 10? Negative 5, negative 5. Yeah. So this actually turns into 0 is equal to x minus 5, x minus 5. So my solution is x equals 5. Okay, so what if we didn't see that? Let's try to complete the square with this. I would have 2x squared minus 20x is equal to negative 50. I would divide through by 2, and I would get x squared minus 10x is equal to negative 25, right? And what would add to both sides? 25. Negative 10 divided by 2 is negative 5 squared is 25. So I have x minus 5 squared is equal to 0. I square root 0, I get x minus 5 is equal to 0. So x is equal to 5. But what if I didn't want to use completing the square? I know you guys sometimes hate completing the square. So let's use the quadratic formula. For the quadratic formula, I don't really even need to factor out the 2. A is 2, B is negative 20, C is 50. And then I'm looking at this right here, standard form. Right? Okay, so the opposite. Maybe you just wanted to sing a song. The opposite of B plus or minus the square root of, okay, I'm not going to do that in my head. B squared minus 4AC all over 2A. Okay, chip away at the radical. I've got negative 20 squared, put it in parentheses, minus 4 times 2 times 50. Oh, 0. Okay. So that means I've got x equals 20 plus or minus 0 over 4. Well, that's just 20 over 4, which is just 5. Yeah. How would that be plus or minus 5? The plus or minus goes on the 0. You know, it's negative 5 is technically not a solution to this. It's only positive 5. The plus or minus was attached to the 0, Does that make sense? There's only one solution. Like if I go to factor this, x plus 5 is not a solution over here. You know what I mean? Yeah. Questions about that? Okay, let's keep it going. Write a quadratic equation with these zeros. Okay, so this is the one where we're backward, right? I start with by saying x equals 3, x equals negative 5. So I would say x minus 3 equals 0, x plus 5 equals 0, right? We get them set equal to 0, and then we find the function. We'll say f of x is equal to x minus 3, x plus 5. I know that if I say those are my zeros, that means these are the corresponding factors. And if those are the corresponding factors, I multiply those things together. So f of x is equal to, let's FOIL first, outer, inner, last. So f of x is equal to x squared plus 2x minus 15. Questions there? And again, if any of you, I am recording this, so if you guys wanted to go back and watch this and see these problems done over again, that's totally your call. All right, let's keep it rolling here. Number 8, write the function in vertex form by completing the square. Okay, now people, again, please don't be one of those people, but someone on the test on Monday is going to try to find the zeros. Don't try to find the zeros. That's not what the question asks you. Write the function in vertex form. That's all I want you to do. Rewrite the function in vertex form. What does that mean? Well, that's these weird ones that say, okay, f of x is stuck on the left side. You cannot do anything to f of x. You can only do something to the right side of this function. I don't want x equals. In the end, my function should still have that f of x equals. Right? If I go to my answer blank, it shouldn't be x equals. It should be f of x equals. So now I say, okay, I partition off my first two terms. I leave my 23 sitting out there. Can I complete the square using my first two terms yet? No, I have to factor out the 5. So this means I've got f of x is equal to 5 x squared minus 4x. I factor out the 5 from just the first two terms. And now I complete the square with just those two terms inside the parentheses. What adds to fill in my blank? 4, right? Half of negative 4 is negative 2, squared is positive 4. Okay, if I added 4, remember, whatever I do here, I have to do the exact opposite out there. Okay, if I added 4, what do I do to the outside? Subtract what? 20. Ooh, weird, right? 20. Why? Because of the 5 that we had removed. Think about what happens if I factor in what I had factor out. 20. I didn't actually just add 4, I added 20. So I've got to subtract 20. That weird one, if you factor out an a value, you have to take that into account when you subtract that away. So f of x is equal to 5, x minus 2 squared plus 3. So the vertex of this is at, sorry, here, hold on. X minus 2 squared plus 3. So the vertex is at 2, 3. Yeah, Joy.
When is it that it would be, the plus 20 would be on the other side of the equal?
When I say find a zero.
Okay.
Yeah. Yeah, when I can work with both sides of the equal side. See, like this side, this time I can't break the f of x. And we know that by the directions. Right, the function in vertex form. Questions? Yeah.
In the second part,
Yeah.
where did you get the 4 from?
I factored out the 5. That 4?
The second 4.
This 4.
Yeah.
I took negative 4, divided by 2, squared.
Okay.
That's completing the square.
Oh,
You might want to go back and rewatch 5-4.
yeah, probably should.
That might be a good idea. Both days. Both days. Questions anymore on this one? All right, take a look here. Okay, do I tell you how to solve? No, you can do whatever you want. But this doesn't have a b term, does it? So if it doesn't have a b term, man, the best, now how do I know it doesn't have a b term? You don't see just an x, right? So if there's no just x, just solve directly. Subtract over the 125. 5x squared is equal to a negative 100, oops, not 150, 125. I divide by 5, okay. 125 divided by, oh, that's just, negative 25. Okay, plus or minus the square root of, don't forget about the plus or minus. Don't forget about the plus or minus. What's the answer here? What's the square root of negative 25? 5i. Plus or minus 5i. Square root of negative is an I. Any questions about that? Okay, let's keep it rolling. Now, this is in contrast to problem number 8. Look, find the zeros by completing the square. This is when I want, here's my answer blank, x equals. Right? This is when I want x equals. This is when we can do, something to both sides. Okay, I was nice to you here. X squared plus 4x plus 85 is equal to 0. Why do I say I was nice to you? Why do I say that? What implies me being nice to you about completing the square? What do you notice about, well, is there an a value? No. Okay, so that's nice. What do you notice about b? When I say it was nice to you, what do you notice about b? It's positive, that's, yeah, but it's even. It's even. I can divide by 2. Here's what I mean. I have x squared plus 4x is equal to negative 85. What do I add to both sides? Oh, that's easy to calculate because 4 is even. 4 divided by 2, 2 squared, 4. I add 4 to both sides. And this is the case where I add and I add. Like I can do something to make my equations equivalent. So we have an x plus 2 squared is equal to negative 81. Okay, now when I square root negative 81, plus or minus 9i. Right? The square root of negative is an I, square root of 81 is a 9. So don't forget about the plus or minus either. And then I finish by subtracting the 2 over to the other side. Negative 2 plus or minus 9i. Questions about that? See, this is the difference in the problem between number 8 and number 13. Number 8 said to find the vertex form, like rewrite it in vertex form. Number 10 says find the zeros. Okay, a couple more to do. Keep trucking. What does this tell me to do if I ask for the type and number? What am I actually just finding? What's that called? Not determinant. Discriminant. Discriminant. Remember, the discriminant is the piece underneath the radical. The b squared minus 4ac. Remember that if the discriminant is positive, it's 2 real. If it's negative, it's 2 non-real. If it's 0, it's 1 real. Right? Okay. B squared, so A is 3, B is negative 4, C is negative 1. So B squared minus 4AC. Negative 4 squared minus 4 times 3 times negative 1. 28. I don't really care about the fact that it's a 28. I care about the fact that it's positive, because that tells me 2 real solutions. Okay. Again, when I ask you this, find the type and number, that's asking you find the discriminant and use what you know about the discriminant to tell me whether there's going to be real or non-real solutions, and if there's 1 or 2 of them. Okay. Find the zeros by the quadratic formula. Sweet, I love using the quadratic formula. A is 1, B is 9, C is 2. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, chip away underneath the radical. 81 minus 4 times 1 times 2, that gets me 73. Oh, that's easy. Negative 9 plus or minus radical 73 over 2. Why do I say that's easy? Because 73 is fine. We're done there. The only other thing that you should really check is to see if this fraction was reducible. And it's not. 9 over 2 is not reducible. So we're done. Last problem. Here, find the zeros using the quadratic formula. Okay, quadratic formula again. Perfect. I like the quadratic formula. A is 2, B is negative 1, C is 4. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Be careful, that's a positive 1. Positive 1 inside the radical right there. B squared is a negative 1 squared, which turns positive. Okay, now we go underneath the radical. It's a 1 minus 4 times 2 times 4. Uh-oh, negative 31. So 1 plus or minus the square root of negative 31 all over 4. Remember that you cannot leave it like that. You have to bring out the I. 1 plus or minus I radical 31 all over 4. Questions about that? Yes?
Would you leave the 1?
Yeah. The only reason you could have that to go away is if it was a 0. Then it would be able to go away. The only other thing beyond this review that I could ask you is to prove the quadratic formula, okay? Which I suggested that you do on the back. So, I've got 5 minutes. I think I could do that in 5 minutes. I'm not going to expect you to write this all down as we go. If you need to, and I just think this is good thing to have on video again. If you need to, come back and rewatch it on the video. Okay, so we've got ax squared plus bx plus c equals 0. Remember, always rewrite your given. Don't skip steps. Subtract the c over. Ax squared plus bx is equal to negative c. Divide through by a. So I've got x squared plus b over a. X is equal to negative c over a. A. And then I do a little preliminary work. Ooh, we do a little preliminary work. We take b over a, we multiply it by 1/2, dividing it by 2. We get b over 2a, and then I need to square it, so b squared over 4a squared. That's what gets added to both sides. B squared over 4a squared, b squared over 4a squared. So that means inside the parentheses here is an x plus b over 2a is equal to negative c over a plus b squared over 4a squared. Now, I have to get common denominators there. I multiply top and bottom by 4a. Multiply top and bottom by that fraction by 4a. And now I can combine like terms. X plus b over 2a on the left side squared gets me a negative 4ac plus b squared all over 4a squared. Now, at this point, I want to just kind of flip the order of my numerator. X plus b over 2a squared is equal to b squared minus 4ac all over 4a squared. I square root the other side. X plus b over 2a is equal to plus or minus the square root of b squared minus 4ac all over 4a squared. But remember, when I square root a fraction, I square root the top, I square root the bottom. So this gets me an x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac, all divided by, well, the square root of 4 is 2, the square root of a squared is a. Subtract over the b over 2a. X equals negative b over 2a plus or minus square root of b squared minus 4ac. And so x equals the full quadratic formula, the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Stop button. Okay. Should have did that in like 3 minutes. Come on now. Remember, this is the back page of your test. That is the back page of your test.
Wait, why'd you stop putting it in parentheses?
This,
Oh,
because I square rooted the other side, yeah. Again, you can memorize this, but it's a good idea to understand what's happening, to understand that all we are doing is completing the square. Okay. All right, so long, everybody playing along at home. I'll see you all later. Have a good weekend.